We start chapter 5.2 asking the question, how many factors does a number have? Specifically, think about how many factors, right? How many numbers multiplied together give you 144? How many different numbers? The factors, right? How many is too low? How many is too high? And think about, man, that's a lot of numbers, right? However, was a discovery of being able to count how many factors a counting number has. And there's a formula here. I'll explain it. It looks very complicated, but it really is not that bad to implement. And so when we look at this formula and then look at these examples, we can see them. They're already done. How many factors does 144 have? Well, the first thing you need to do is convert that number into a product of primes, product of distinct primes, which we already know. Fundamental theorem of arithmetic. Fundamental theorem says that we can represent any number as a product of any counting number as a product of primes. And so we revisit that idea to then count how many factors a number has. And so again, what happens is after you have your prime factorization, what you do is you take the exponents of those prime numbers. You see the exponents here. Add 1 to them and multiply. Now, we don't get into why it works. We're just going to actually implement it right now. And so then you can see what is going on here. Right, and so look at those examples there. So now let's do this one here, 450. How many factors does it have? Your first task is to write it as a prime factorization. And so then you see 450 is 2 times 3 squared times 5 to the power of 2. And so from there, you will see in red I have the exponents, and then you add 1 to each of those exponents and multiply. So then we would conclude that 450 has 18 factors. Go ahead and try one of your own, or again reproduce these, or again for homework you'll be able to practice that. But this complicated formula simplifies the process of finding how many factors we have.